Hello, and thank you for your interest in my course, Survey of Python for GIS Applications. There aren't any formal prerequisites for this course, but if you really have no experience with programming, you may find that it moves a little bit fast for you, and you may benefit from taking a course that's more suited for complete beginners. I don't assume that you know anything about Python, but if you really don't know what a variable is, or what an array is, or what a function is, or things like that, you may find me moving a little bit quicker than you'd like. So you don't have to know Python, but I do assume that you have some kind of programming background in some other language. So the first thing we're going to talk about in this course is what is Python and what are some of its advantages and disadvantages. It has a lot of advantages. There are a couple of disadvantages too, and I'll be honest with you and talk about both. And we're going to go over what I refer to as the Python ecosystem. And that encompasses both the Python language itself and then also some things that you'll need to know for working with Python, like how to find and use third-party packages and some things like that. And we'll talk a little bit about the culture and philosophy of Python. These are some things that I really like about Python, is that because it's an open source language, there's a community built up around it. And even though Python is really flexible and allows you to do almost just about anything that you want, as we'll see, there are also some guidelines that have been put forth by the community to kind of keep everybody on the same page, even if those guidelines aren't rigidly enforced. And then we'll go over the basic Python operations, such as variables and operators, expressions, some of the different data structures available in Python, what are functions and what are objects, and things like that. So we'll see how all of these things are implemented in Python relative to some other languages that you might be familiar with. And then we'll talk about the Python environment. So what's a code module? What's a package? What are virtual environments? How documentation is handled in Python? And also talk about unit testing, which is not anything that's specific to Python. However, Python has some powerful tools, and so we'll go over a little bit about how that's implemented in Python. And then we'll dig in and start working with some data. And so we'll start with interacting with the operating system and how to access files and directories and things like that. We'll see how we can read and write text files and also read and write structured data files such as CSV files or JSON files. And then we'll look at a Python package that's available just for reading and writing shapefiles, and we'll look at that briefly. But as we'll see later on, that there are probably better methods available for working with shapefiles. And we'll also talk about working with data that's stored in a database, like a SQLite database or a PostGIS database. And this is really powerful because a lot of geospatial data today is stored in spatially enabled enterprise databases like SQL Server or PostGIS that allow you to store and analyze spatial data and also provide multi-user access to that data. And then we'll shift gears a little bit and talk about the Python data science stack. And so if you've been interested in Python and you've done any kind of research on your own, you may have come across these terms and maybe weren't 100% sure on what they were or what they mean. And so we're going to talk about things like Jupyter Notebooks, which allow you to document step-by-step your analysis along with both interactive code that you can modify if you want and also see the output of that code. We'll talk about the NumPy package that's used for really fast mathematical operations and really fast array operations. And this is the basis of raster operations in Python. Matplotlib provides graphical output, so it's used for both charting and also displaying maps. Pandas is another package that provides the ability to read data into a data frame that you can use for analyzing data. So this is similar to an attribute table or a database table, but it provides some really powerful tools for working with data. And then stats models is a package that we'll look at just briefly, but it's used to fit and analyze statistical models in Python. So maybe you'll want to conduct a formal statistical test of a multiple linear regression model or something like that. So we won't go into a whole lot of detail, but we'll at least get you started. And then there are some geospatial extensions to the Python data stack. Fiona is a package that allows you to read geospatial data from a number of different data types, and Shapely provides a lot of methods for analyzing that data. And GeoPandas is an extension to Pandas that again allows you to work with geospatial data. And you can plot simple maps and do a lot of spatial analysis right from within GeoPandas. And we'll look at the raster.io package, which is built on top of NumPy. And it provides the ability to read several different raster GIS formats into a NumPy array and work with that data in NumPy and convert back and forth between cell coordinates and geospatial coordinates. And we'll look at the GeoPy package, which allows you to use several different geocoding services to convert street addresses to longitude and latitude coordinates. And finally, we're going to switch gears and talk about how to create programs that have graphical user interfaces. To do that, we're going to use a package called PyQt. And there are a number of different packages that can do that, but Qt is the one that's used in QGIS. And so that's the one that we're going to use. It's as good as any that are out there, and if you ever want to create any extensions to QGIS, then you'll already be familiar with it. And so having said that, I should mention that one thing that we won't be covering in this course are any of the desktop GIS APIs, like ArcPy for working with ArcGIS or PyQGIS for working with QGIS. If your interest is ultimately to work with one of those packages, this course will still be really valuable, I think, and it'll provide you a really good background in Python. But I think you might also find that for a lot of applications, you'll be able to do what you need to do without going through the complication of learning ArcPy or PyQGIS. For a lot of applications, you'll be able to just open a geospatial data file directly and do what you need to do. In fact, you'll be able to do some things in Python directly that you would need either advanced licensing or an extension in ArcGIS. And those same limitations would apply if you were trying to work with that data in ArcPy. But if you work with it directly in Python, there's no licensing or anything like that involved. And so that's really handy. So if you have interest in this course, you can go to my blog at millermountain.com/geospatialblog. And on the courses page, you can see a link to this course and all my other courses as well. You'll be able to get this course for $20, which is cheaper than you'll ever find it on udemy.com. The course has over 13 hours of content, and I hope you find it useful.